Screencast 20.6, a brief solution to a balancing redox problem. This is the quickest version that we'll show where we balance a redox problem. And in this case, we have oxalate turning into carbon dioxide, permanganate turning into Mn2+. So we'll write down each half reaction. For example, we can do the permanganate turning into Mn2+. Permanganate's fine, but we have 4 oxygens there, so we'll have to add 4 water molecules to this side. In turn, we'll have to add 8 H pluses to that side. Then we'll have to balance the electrons. For this one, we will have 2 carbons on this side and only 1 on that side, so we'll have to double that up. That'll give us 4 oxygens on each side, so we'll then only have to balance the charge. We'll then do a multiplier to make sure that the charge is offset, and we'll add them up. I did that in detail because it does this kind of quickly here. So let's have a look at what we did. Here's the permanganate side. MnO4- turns into Mn2+. That's simply copying that down. Now the manganese is fine, but we need to add 4 H2Os here to balance oxygen, right? That gave us 8 H plus that we had to add to that side to balance hydrogen. And then if we add 5 electrons to this side, that makes this side 2 plus, and it makes this side 2 plus, so that looks great. For the oxalate, we begin by recognizing once again that we're messed up in terms of carbon, so we double the carbons on this side, fine. And that makes it so the oxygens are all set, 4 on that side, 4 on that side. But we're not good in terms of charge because we're -2 on this side, so we add 2 electrons on that side. Double check everything's right and you find that it is, but 5 electrons here and 2 there, the common multiple is going to be 10. So multiply this entire reaction by 5 and that entire reaction by 2. Now some people do that out and write down everything. Or you can try to just keep it just like it is and combine. And so we have 10 electrons. We have 16 H plus because we're multiplying it by 2. And we do have 2 permanganates turning into our 2 Mn2 pluses and our 8 H2O. So we did write it all down. And we have the 5 here and 10 there for the CO2s. So we actually did rewrite it to make it easier to combine. And when you do, you'll see the 10 electrons here, offset the 10 electrons there, and we just add her up, and it's in acidic medium, so we don't have to add any hydroxide in the end, and check that everything is balanced. For example, carbon, 10 carbons on this side, 10 carbons on that side. You'd see the whole thing is balanced. And this is a brief solution to a balancing redox problem.